Hello, let's talk about that highly unpopular topic of upper and lower bounds. So let's just start off by going through the basics, and that is that if you've got a number like 8.34, and you've been told this is accurate to 2 decimal places, find the upper bound. And basically, because this is a quick video and just telling you how to do it, you basically just add on a 5 at the end. This always works. Okay, and if you go below, you then subtract the same amount. So instead of adding 0.005, you subtract 0.005. So in this case, we get 335. That's the upper bound. That's the lower bound. Now that's correct to 2 decimal places. And then you can have some other ones. So you might have, say, just 8, and that's to the nearest whole number. And then again, you just say, okay, well, it's 8.5. And then 7.5 is the lower bound. And then that's integer. It's the nearest integer, or whole number. Now you can get slightly different things where you've got a number like 100 grams, and this is to the nearest 50 grams. Now you've got to be a bit more careful here, because if we're doing to the nearest 50 grams, then basically what you have to do is divide that 50 by 2 to get 25. And then if you add that, you've got your upper bound. And if you subtract that, you've got your lower bound. Now, I'll try and explain that a bit more. So imagine anything up to 125, if you round that to the nearest 50, then that will go down to 100. Because the nearest 50s are 0, 50, 100, 150, and so on. So anything above 75 will round up to 100. So what you realize is that 2 decimal places is a bit like 0.01. If you divide that by 2, you get 0.005. And so essentially what you're doing is dividing the nearest thing by 2 and then adding or subtracting that. But you don't have to think of it in such complicated terms. You can just basically remember that if they give you a decimal, you just add on the 5 at the end, and that always works. They never say, here's a number 7 to 5 decimal places, because they haven't given it to you to 5 decimal places. They'd have to say 7.000000, and then you could just add on a 5. So you can pretty much just always add on a 5 or subtract the same thing. Okay. One more thing, let's just mention, because it's worth it, is let's say you've got 2 kilograms. And again, to the nearest 50 grams again. Now, you've got to be careful, because 50 grams is the same as 0.05 kilograms. So 25 grams is 0.025 kilograms. So, am I recording? Yeah, I'm recording. Good. So when you're adding that, this goes to 2.025 and then 1.975 kilograms. So just be aware of converting between units. That sometimes happens. So let's now talk about the next thing with this topic, which is more of an application and actually requires you to think a bit more. And that is when we're talking about subtracting or dividing. So say you've got this number, A is 17.8, and that's to 1 decimal place. And you've got B is, say, 16.35 to 2 decimal places. And the question is, find the upper bound of A minus B. Okay? And let's just take a step back and think about what we're doing. So over here, let's just have a think. And basically, if we do upper bound of A minus B, we can pick the upper bound or the lower bound of either number, but we want to find the highest number in the end. So what you do is you go for the highest number of A, because we're adding A, so we want the highest of A, and we're subtracting B. Oops, let's get this in screen. If we're subtracting B, then we actually want to subtract the smallest version of B, or the lower bound, of B. Bother, made a mess there. Lower bound of B. And let's talk about the lower bound of A minus B, in case that came up. So the lower bound, we pick the lower bound of A. And this time we want to actually subtract the largest version of b, the upper bound of b, because that will give us the lowest number overall if you subtract a big number. So in other words, big minus small gives you big, but small minus big gives you small. So going back to this, let's just quickly double check what these numbers actually are. So sometimes it's worth just writing out both the upper and lower bound. That gets you a mark normally. So in this case, this would be 17.85, just add a 5 on the end, and then 17.75. And then similarly, let's just check this one, 16.355. This is where it's quite useful to write it down actually, because it can get a bit confusing here, because it's 345. We're subtracting the 0.005. Right, now we can do this because this is just going to be the upper bound of A minus the lower bound of B. And then we've worked those out, so we can just read them off. What is it? 17.85 minus 16.345, that's the lower one. Use a calculator if you want. And you get the answer, 1.505. Done. Now, the next one is division. Now, you might have seen this one before, but let's go through it. And I'll do an example this time with some other numbers that might help. So let's say you've got mass is 3.6 kilograms to the nearest 50 grams. And you've got the volume of something is 800, say. And let's do, we haven't done this one yet, nearest 10. So the nearest 10 we can think about. Hopefully you can think about that, what I've said before. Okay, and the question is, find the lower bound of the density. Now this requires you to know that density is mass divided by volume. Must know that. And assuming you do know that, then you can get on with this question. So let's just go over here like before and just talk about what is the upper bound of a division. We're dividing two quantities. What do we do? Well, we want the highest number. What we want to do is take the highest number in the numerator, highest A, and actually divide it by the lowest B. That will give you the biggest number. So big over small gives you big. And as you can probably now tell, for the lowest number, you want the smallest, over the biggest. That gives you the smallest number. Okay. So let's go back to this. And, we actually now need to write down what. So lower bound of density is going to be the lower bound of mass over volume, which is going to be the lower bound of the mass divided by the upper bound of the volume. And now let's just work out what those things are. So again, with 50, remember that's 0.025. So this is actually 3.6 goes to 3.625, or let's just write it down, 3.575. And now 10 milliliters, hopefully you've had a chance to think about this a bit. Actually, if we half that, we get 5 milliliters. So anything between 805 and 795 will round to 800, to the nearest 10. Okay, so now we just put those numbers in and see what we get. So we've got, I'm getting lost now. Lower bound of this, so that's 3.575 divided by the upper bound of this, which is then 805. And then you can do that on a calculator. Now there's one thing just to mention about calculators here. If you get a number like this, and it says 4.44 times 10 to the minus 3, you might not want to write it like that. And if you just press Shift Eng, does nothing, press it again, and then it actually writes it as you would want it to be written. So 10 to the 0, that's just 1. So that is what the number is, 0.00444. And I didn't actually specify how accurate we're doing this, but typically it would be, if it was three significant figures, then you could just write down 0.00444. Okay. In terms of the units, I think you always, it gives you the units, so you don't have to fill in the units. But yeah, in terms of getting the numbers right, that's what you'd have to do. So really, I think that's about as hard as it gets with questions on density and uppers and lower bounds using not just decimal places, but things like grams and milliliters. So just be careful about that. But if you remember that, then should be fine. Okay, hope that was helpful. Bye-bye. See you next time.